This is Software Engineering Radio, the podcast for professional developers on the web at se-radio.net. SE Radio is brought to you by the IEEE Computer Society and by IEEE Software Magazine. Online at computer.org/software.
Hey, this is Jeremy Jung for Software Engineering Radio. Today I'm talking to Wouter. He's the author of The Creative Programmer and a PhD researcher at the Faculty of Engineering Technology at KU Leuven. His research focuses on non-technical skills in software engineering education, and he primarily is targeting creative problem solving. Wouter, welcome to Software Engineering Radio.
Hi, thanks for having me. Really excited to be here.
You worked in industry for over a decade. Why move to academia? What was the turning point there?
That's a good question. The turning point for me was as a coach and technical lead. I also did a lot of job interviews, and we onboarded seniors, we onboarded juniors, and most of the time the people that were new, after a few months, they were technically more than proficient enough to join the daily development cycle. But we noticed that things like, for instance, problem-solving skills, communication skills, teamwork, how to solve a problem in multiple ways, those were things that were really lacking. And we didn't really have a good way to teach them how to do these things because they were really difficult for us to identify in the first place. So those were the things that really interested me. So how do you do it in multiple ways? And that was one of the reasons why eventually I left the industry, and I have been researching the exact topic for the last 5 years in combination with teaching. So that was a really interesting combination.
One of the things you said in your book is you felt like software seems to be doomed to fail.
That's a good way to start a book, right?
Yeah. So what did you mean by that? And what were the biggest problems you saw?
I'm not really sure what I meant by that, but somehow every time we try to develop a big piece of software, it always ends in a big ball of mud, or nearly always. I've been working on more than 20 different projects over the course of the last 17 years, I think. And the ones that were really successful, I think I can count on one hand. So, and of course, there are multiple reasons why. Budget is one of the reasons, mismanagement is one of the reasons, but also miscommunication and miscollaboration is one of the reasons. Hiring the wrong people, nearshoring and not knowing how to handle nearshoring is one of the reasons. Technical debt and ignoring technical issues is one of the reasons. Also, one of the big reasons, in my view, but that's of course really difficult to scientifically back, is not knowing how to approach a problem given a tight set of constraints. We always approach a problem the same way. Once we notice, okay, this is how it works, then the next problem, we just apply the previous pattern because we know this worked. Oh, no, it doesn't. No, I don't really know what to do. So you need to come up with multiple ways to get around that. And that was one of the things that I've been researching.
So let's talk a little more about examples of those kinds of constraints. What were things that you saw both from your research or just talking to people in industry?
Well, if you're referring to constraints specifically, then perhaps one of the good examples is working with legacy software. We all still daily touch it, and nobody really wants to do it. We can debate the definition of legacy software, but it mostly boils down to being afraid to change something because something will break, but you don't really know when it will, and you usually notice it 2 weeks too late when the thing has been shipped in production, and of course there are no tests for it. So how do you approach something like that? For instance, let's say an old COBOL software or Visual Basic software where things like unit testing and pair programming and Scrum and the new agile techniques weren't usually that common back in the day. We could still apply those principles to the legacy part of the software. And most of the people who approach that, they just say, no, we can't do that. While in effect, you can. And there is for instance, there's a Visual Basic 6 XUnit toolkit which allows you to write unit tests. That's possible. It's not a lot of fun, but you can still apply the modern techniques using the old software. development tools. In another project I've worked with, lots of domain logic was written in stored procedures in Oracle in the database itself. That's, of course, a really, really bad decision. But we couldn't change that on time, and we had to change something within, let's say, a week or 2 weeks, so you can really refactor out everything. But after a bit of searching, we found out that there was a way to unit or integration test one of those stored procedures. So you have to be open to the idea of applying modern techniques to the old part of the software. Well, most people in the team just said, let's just roll with it and change stuff, and we'll see what we end up with. And most of the time, that means breaking things.
It sounds like this may be the combination of facing a constraint, but then not restricting yourself based on what used to be. And maybe that's, I don't know what you would call that. Maybe it's a form of curiosity, a form of thinking that, hey, even though this is old technology, that doesn't mean I have to do everything also in the old way.
Yeah, I think it's both. In the book itself, we discuss 7 distinct themes of creative problem solving, and well, they're distinct, but they're still highly interconnected, right? So curiosity and critical thinking are 2 different domains, and constraint-based thinking is a third one. And everything is highly interconnected, which means a lack of critical thinking of just saying this is old software, we can't really change anything, results in taking a certain path which could have been a better path, but you just don't really see it or don't want to see it. So it's a combination of still being curious, what if we could do something like that, and asking the right critical questions, challenging your colleagues and saying maybe this can be done within the time frame. So yeah, it's a combination of different things, like everything in this world, of course.
Yeah, and that makes sense to me, the combination of critical thinking, curiosity, the constraints. Your book specifically is called The Creative Programmer, and I think the word creative can mean a lot of different things to different people, or it's just fuzzy, right? When you say be more creative, what does that even mean? So
yeah, I think that's the biggest problem if you use vague words like creativity. And most of the time, if I ask my wife, what do you think is creativity about, then she'll mention something like colored pencils or art or design or things like that. Something visually interesting, something novel. That depends on the domain, of course, you're in. And we're interested in creativity in the domain of software engineering and not just in art. And if you take a look at the existing research of cognitive psychologists who have been researching creativity for the last 50 years, there's a lot of evolution in the definition. Of course, there are hundreds of definitions, but the general trend was that creativity is 3 things. It's got to be original, it's got to be applicable at the task at hand, and it's got to be qualitative, so it has to maintain a certain degree of standards. But that doesn't really take context into account, right? So this creativity is much more than just those 3 things. So the researchers have evolved from that basic definition to a more socio-cultural one, which means, in practice, it simply means creativity is if someone says it's creative, then it's creative. So it's a social verdict, right? Creativity in isolation means nothing. I can't say for myself that I'm creative. I can only say it because I'm comparing my things with the things someone else made. And if I've never done something like that before, then I'm creative, even though you think it's not creative at all because it's been done 100 of times. So there's a lot of different things to take into account when we are approaching creativity, right? But the thing we're most interested in, of course, in software engineering is solving problems. So we're not just being creative because we want to be creative or for the fun of it. We're being creative to solve something. So creativity is used as a tool, not just as a thing in itself, which is also fine, of course. It can also be something really interesting, but you have to take the context into account.
And sometimes when you hear the word creativity in the context of software, someone might write some software that seems really interesting or unique, but is very difficult for other people to understand. But they say like, oh, but it's very creative, right? So I wonder how you distinguish between good creativity and maybe not so much.
Then we use creativity with the air quotes, creativity. No, yeah, that's of course, that depends on the team you're in. If the whole team thinks that's a good way to approach the coding problem, then who am I to judge that it's not creative at all? If you move from one team to the other and you think you're not creative at all, but in the next team you're applying a principle you have been applying before, and everyone thinks, whoa, that's an interesting way to approach a problem. That's really creative. And you're like, no, it's not. I've been doing that for like 5 years, but the people surrounding you in the new team, they weren't really aware of it. So I think that depends. It's not really that interesting to stand still too much about and to discuss what you think creativity is really about. I think one of the difficulties, of course, is pinpointing the definition, and we as researchers, we're also not really sure which of the published definitions should we use as a starting point to research this topic in software engineering, right? In software engineering. So what we did was actually just go to developers, go to different companies in different countries, and we surveyed them. We just asked them, what do you think creativity means as a software engineer, as a software developer? And the result is those 7 domains. So after lots of processing, the data processing, identifying shared and key concepts, the result is actually the 7 chapters in this book.
And maybe just really briefly, you could say what those 7 are.
Yeah, sure. So the first one is called technical knowledge, which means you have to have some sort of technical standard to be able to be a little bit creative in it. As an example, for instance, if I'm a Python programmer, chances are high I can speak Python and I can be a little bit creative in my Pythonic code. If I've never programmed before, then it's really difficult for me to be creative at Python programming. If I ask my wife right now, can you write something creative and original in Python? I don't really think that's going to be interesting to put in production, right? So you have to have some sort of technical baseline. Knowledge is an important part of creative problem solving. The next one is called communication or collaboration, which means that, like I said before, creativity doesn't really happen in isolation. It's the most interesting solutions happen in conjunction with other people, and those other people, by preference, should be a heterogeneous group, not like-minded people. So you can have this interesting discussion with someone from, for instance, biology, or someone from architecture, and they might say, oh, we're doing things like this. And then we as a software engineer would say, that's interesting. Perhaps we can apply this pattern in software engineering. And then you have results like asynchronous programming and like service buses, things like that, all originated beyond the scope of software engineering. So that's communication or collaboration. The third one is constraints. We already talked about that. The fourth one is critical thinking. That's also briefly mentioned. Critical thinking, and then curiosity, getting out of your comfort zone, not being afraid to ask questions, motivation, to have that creative urge to keep on trying to tackle that specific problem instead of giving up. And next we have a creative state of mind. With a state of mind, I mean being in a certain flow. The flow is a really popular word right now. Having those aha moments, the shower thoughts, and doing something with our ideas and refactoring or reiterating on those. That's what I call a creative state of mind, which can be personal or can also be a corporate state of mind. We can talk about that in a second. And then lastly, you have practical creative techniques. If you don't know how to zoom out on a problem and approach it like a bird on a top-down view, and then zoom in back on the method you're writing to get an overview, and then say, oh yeah, okay, no, I need to write this line because in another component it's been done that way. If you don't know how to do these techniques, then of course your creative input is going to be limited. So those are the 7 main themes of what I call being a creative programmer.
And you talked a little bit about this earlier, where you have this questionnaire where you evaluate someone's state as a creative programmer. And I wonder if you can give some examples of ways people filled out that test and how it caused them to reflect and identify the areas where they could improve or identify areas that were problems in their organization.
Yeah. The test was developed with software engineering students in higher education in mind, but it is also really interesting to take that test as an engineer in the industry. Why? Because some of the questions are like, during this or this or this project, I asked help from colleagues. That's a really stupid question, of course. For students, most of the students would answer, yes, I consulted my friends who are also students next to me. And then you have the next question, which is, did you consult your peers, the teachers? Did you ask when stuck? Did you ask something? And most of those students, we learned, are afraid to ask questions because when they approach a professor or an assistant, like I was, they think they're going to be evaluated, and they think if I ask a question, I'm going to look stupid and they will know I don't really know what I'm talking about. But that's a wrong way to approach something, because if they ask a question, perhaps I can chime in and say, did you think about this or this or this? And then they are like, oh, that's interesting. Maybe we could approach it like that. I help them open up a different pathway to the solution. And the next time they approach a similar problem, perhaps they will think about, maybe we should do it like this. I know the people in the industry are more used to doing things like that, but those reflect kind of questions are really interesting because most of the time we're not really given the time to think about the way we approach problems. It's just 10 minutes or like 50 minutes, and it's in context of a specific project you're working on. At the end, it'll also say, regarding collaboration or regarding curiosity or regarding your state of mind, you're doing really a great job, or you're doing not so well. Here are a few tips to help you improve or get unstuck.
And in issuing those tests to students, did you get any feedback specifically about like, oh, I wasn't doing this, but when I took the test, I realized there were all these things that I could have been doing, that sort of thing?
Yeah, that was exactly the response. Yeah, and that was really good because I was happy. I thought maybe they have learned something. But we did issue the test with, I think, last year students, first year students, and third grade. I'm not really sure again. But it's not a longitudinal study. So one of the follow-up studies could be a more interesting one, like doing this again within a few years, again within a few years, again within a few years, and then compare the results. Did they learn something? Because if I take a test and if there's a reflective question that makes me think, perhaps I could apply it next time, after 5 minutes, I might have forgotten about it. So in the end, you don't really learn anything. So the most interesting thing is, after like a year or like a few years, or perhaps if they graduated and they went to industry, and after a few years in that company, did they think back about the things in this test? And I'm a bit pessimistic in that regard. I think the answer is going to be no. And in that case, nowadays they have really easy access to my to my research. They just got to be read the book again.
And sort of related to that, in your book, you talk about the concept of, I think you called them dream teams, where you're on a team that creates this stimulating environment where everybody is making each other better, making each other think about things they otherwise wouldn't have thought about. What were some of the constants across teams like that? Like, what was different about those teams that got people into this creative state of mind?
There's a couple of different things, I think. One of them is the environment you're in. By that I mean the physical environment. Some companies, they really take an effort to create a nice place to work, an interesting place where, as a developer, you're happy and you're content to get to the office. Well, of course, post-COVID, most of the people are working from home, so that's their responsibility to get a nice desk and a few plants and things like that. But besides that, besides feeling at home and feeling relaxed and then doing the work, I think it's the relentless curiosity and the endless drive to keep on going and to motivate each other and keep on motivating each other, even when the things get tough and the tough gets going. That was a constant factor. And that's something you don't really often see. And in some interviews that I've read and some interviews I've also conducted, software engineers say the stars must have aligned for this team to to make it into existence, because this was one of a kind opportunity. I've also worked in a few. I've been lucky enough to be in a really interesting and really cool team, and there was so much learning from and to, and everyone was motivated to go to work. And the next project I was on was with another team, and it was completely opposite. So it's really tough to pinpoint and to identify these are the things you need to have a super performing team and a dream team, for instance. There's a lot of research on that, and the results of the research, depending on the paper, are completely different. So, yeah.
Yeah, so we're still stuck just hoping the stars align anytime we join a new team.
There's a few shared things, like, the curiosity and the motivation, but of course, if you have a boss who yells at you, then you're not really that motivated to come to work each day. So these are the obvious things that I guess everyone will mention, but the less obvious things, I think we're still trying to identify and dig into that.
I mean, you gave the obvious example of you have, an abusive boss or something like that. Of course, nobody, that's not going to be a good environment for anybody, but...
Should I mention names right now?
But one of the things you do talk about in the book is this concept of social debt versus just technical debt. And I assume that example you just gave is an example of that. But what are some other examples of things that people may not be obvious to people that this is a problem when I'm on a team?
That was a really interesting concept that I dug up, which is research from a professor in Germany, and he coined the term social debt. There are lots of what he calls community smells instead of code smells, which are part of the social debt. For instance, if you have what he calls a lone wolf in your team, which is this person coding away in his corner, committing stuff, not really discussing anything, and just going at it, not really sharing his knowledge, that's obviously a big problem, right? These social issues prevent the team from sharing ideas and from being more creative. So one of the questions you could ask is, of course, if there are social issues in a team, it's not going to be, that performant. But what does that have to do with creative problem solving? Well, everything, I think, because if you don't collaborate, you don't share ideas. If you don't share ideas, you're not refining ideas. If you don't refine ideas and have multiple ideas and critically evaluate each idea, then you're just doing the same thing over and over again, and it's not going to be really great, right? Other examples beyond lone wolf are like, I think it was called information black hole, which is there's lots of domain knowledge in certain projects, there's lots of technical knowledge, but nobody's writing down anything. There's no internal wiki. There's for instance, only fleeting Slack messages, which are not really collected. So if a few people leave the company and new hires come in, they have no idea where to start. So that's another one.
It seems like the examples you gave there, the first is this social aspect of where you don't feel comfortable to bring up ideas or try new things because you feel like they're going to get shot down or you're going to be scolded. So that really puts a damper on how creative you can be. And then I suppose because one of the things you mentioned earlier was that if you don't have the technical knowledge, then you don't really have the information you need to come up with creative solutions or new solutions. And so, if everything is just spread out randomly, you don't have access to the information, so you can't get any insight from it.
Yeah, and it's not just technical knowledge, right? Because you also have no idea or no clue what the constraints are about, which constraints have been identified. You constantly have to poke your colleagues and ask them, what's this about? What's this about? What's this about? Which means after a few weeks of constantly poking, they're constantly out of the zone, so their creative state of mind is also reduced. Your curiosity is reduced because you don't really feel like asking questions anymore. There's no easy way to access everything. So again, it's intertwined.
You mentioned curiosity there. I wonder if you can give some examples that you've had from speaking to other software developers about something where their curiosity really drove them to a novel solution or a creative solution.
I'll give a simple example. Some software development companies, I think most of them, hire front-end software engineers and back-end or full stack or whatever you can call them. But most of the times there's a hard split between them. A few teams work on the front end. It's decoupled from the APIs, which are in the back end. The back end might be in Go or in Java, whatever. And the front end is usually in Node or in Vue.js or in React or TypeScript or whatever. And most of these, of course, I'm not saying everyone, but most people we interviewed, like the front-end engineers, they're not really keen on doing anything in the back end because, it's from those guys, and the other way around. But if your curiosity would prevail and you would take a look at what they're doing, perhaps one of those things that they're doing, that for instance, enterprise design patterns they're applying, running different nodes on different clusters, or just that general concept. I'm just saying something, right? Could also be applied on the thing you're doing right now in the front end. Some people I've interviewed said, I'm a Java engineer and I don't want to do anything with .NET. And that really blows my mind because I've been doing Java for 6 years. I've been doing .NET for 5 years. It's the same. It's exactly the same. The one thing is from Oracle, the other thing is from Microsoft. And every few years, .NET steals something. The .NET Core team steals this syntax from Java and the other way around. So I don't really get why people are so locked into that way of programming. That's a bit sad, I think. So that's the lack of curiosity in my view.
So I suppose it's just being open to learning new things.
Exactly.
And it also ties a little bit into, I think in your book, you mentioned how in a lot of contexts, it's important to be a generalist in some sense, right? To like you were just saying, not just say, I do front end work, so I'm only going to look at the front end, but actually be at least somewhat aware of how the back end works, be able to talk to those developers, have domain knowledge so that you can basically come up with better solutions rather than just focusing on just one thing.
Yeah, and it's just a way to generate more insight. That doesn't have to mean that you as a front-end engineer have to start developing back-end stuff. You can have your preference, that's fine. But it's just a way to get more ideas into your brain and to get started with your front-end stuff or with your back-end stuff, whatever. But you don't really have to limit yourself to gathering insight from just one specific subdomain.
And another thing that you talk about in your book is this concept of critical thinking. I think people probably have a vague sense of what they think that means. Maybe you could explain what it is in your words.
Well, there's the high-level critical thinking part, which is, of course, related to lots of psychological fallacies that we have, like biases, like confirmation biases or things like that. There's lots and lots of different things out there regarding those biases. But in context to creativity, there's this creative state diagram, so to speak, in which you first incubate. You have an idea, you're thinking about it, you're just doing something else, and your subconscious is more or less processing the idea. It's fermenting in your head, so to speak. And then you're participating, which means you're doing the work. Most of the times, it's an illusion that aha moments happen all of a sudden. 90% of the time you're working, and 10% of the time you have those aha moments, but they're linked, of course. But then, even if you have those two, most of the aha moments are crap, are really bad ideas. And you have to have the proficiency or the tool set to identify those bad ideas and the good ideas. So there's got to be, that's what I call creative thinking in context of critical thinking in context of creativity, right? Once you have ideas, which is really cool, first ideas have more ideas. The purpose of being a creative programmer is having more ideas. And then the second purpose of being a creative programmer is identifying and categorizing those ideas. Is it going to be a really good idea or is it going to be a really bad idea? Some people are really hard on themselves and shoot down every idea they have, especially in so-called meetings, the brainstorm events. Most of those events consist of one or two people just saying, this ain't gonna work, that's not good. And that's not a good way to approach any idea. It might be a bad idea, but you first have to take a really good look at it. And perhaps it's a really good idea. So that's the critical thinking part that comes into play.
And are there any examples you came through in your discussions with people or research of where somebody was thinking of an idea and they weren't sure if it was a good idea or not? And to a lot of people, it may have seemed like not a good idea, but it just was surprising. It actually turned out to be something really interesting.
I think one of the recent ones is, for example, if you're working with a legacy software and there has to be some sort of change, but there's not a lot of time to do it. Sometimes there's this brainstorm session, right, to say, okay, we are on a tight budget and a tight deadline. Let's see what we can do. What do you think is approachable? Is an approachable way to tackle this problem? And then most of the team members, I guess, write down post-its, and then you start discussing multiple ideas. But most of the time, those things happen ad hoc, which means you just blurt out something without first noting down the ideas. And as soon as you blurt out something and someone shoots down your idea, then you're less likely to share your second idea. And perhaps that second idea is the one that the team really, really, really needs. But again, that's also one of the community smells, so to speak. If there's one loud mouth which is constantly doing the talking, then the three people in the back are never going to say anything. So it's up to the facilitator to gather everyone's ideas before you move on to the critical thinking part, right? So that's a recent one, I guess.
Yeah, so I suppose it's maybe deciding that when people share their ideas publicly, that you give other people time to see them and think about them rather than immediately judging them.
Exactly, yeah.
And you sort of mentioned this a little bit earlier, but when people are thinking through whether something's a good idea or not, or working through this process of critical thinking, there are assumptions they can make that kind of leads them down the wrong path. Like I think a example I saw in the book is you said there's this first Google hit coding where you have a problem, you search, and the very first thing you see, you go like, oh, okay, this is the solution. I'm going to do this.
Done.
And I wonder if you could talk a little bit to that and the problems with that, as well as other common mistakes, I suppose, people make in their critical thinking.
Yeah, one of the really interesting recent mistakes I see lots of people doing right now is, using Copilot without really thinking, is this a good implementation? AI is really popular right now to help, so to speak, increase the productivity of programmers. But I think it's a bit overrated because most of the things it proposes, it's supposed to help with boilerplate code, right? And not with the heavy stuff that you really have to think about, the domain-specific critical stuff. And if you just copy paste or just say, okay, I'll accept this proposed part of my pattern or the method I'm working on, for instance, a switch case statement. Okay, that's good. Bam. Perhaps it's good, but not for the problem at hand, or in another context, it would be good. So it pays off to stop and think for a moment or two. Is this thing that it's proposing the right thing to do? And if you don't really know, if you're not really sure, then perhaps ask it to a colleague and not ask ask the AI, is this a good idea? So that's a recent one, I think. It's really important as these tools get integrated in the daily practice of software engineering.
Yeah, the Copilot example is interesting because I hadn't thought of it, but like you said, it's almost like the equivalent of picking the first Google result, right? It's rather than it being ranked first in the search results being the proof that it's correct, this is what the large language model gave to me, and that means it's correct. And neither of these things are definitive in terms of whether they're an actually good solution or not.
Yeah, but most software engineers know that they shouldn't really just copy paste stuff from Stack Overflow. I think that joke has passed. But regarding Copilot, since it's new and shiny and it's trained on millions of code bases, they think that's the better way to approach it without applying your own critical thinking mindset. It should still pass that mindset flow inside your head.
Yeah, and the Stack Overflow example, I think something about that is that with Stack Overflow, you can look at the comments other people have left and the alternative solutions, and I find that can often help you along in your thinking through of whether this is a good solution or not. Whereas with the generated code from, say, a Copilot, it's presented without context. And so you really have to force yourself to work a little harder to validate, does this make sense?
Yeah, and one of the new issues I've seen right now is that part of the proposed solution from Copilot gets pasted into Stack Overflow, and people are asking Stack Overflow users, I've got this from Copilot, do you think that's a good idea? So in effect, you're acknowledging that critical thinking from humans still has to be done, but you're not doing it yourself.
And in the end, if you check code in and it's problematic, you can't just say, well, it's Copilot's fault. I mean, ultimately it was you who checked that code in, yeah. One of the later things, and you've mentioned this a little bit before, is this concept of getting into like a flow state or being in the right state of mind for programming. And is there specific things in your research or from talking to people in terms of what that state is like and how you get into that state?
Yeah, I think then we're approaching the work of Cal Newport, who is a professor at MIT. He coined the term deep work. There's this shallow work, which is like answering mails, attending meetings, sending out Slack messages. And then there's deep work, which is concentrated work, really hard thinking, doing the stuff you should really be doing. And for that, we could talk a little bit about the environment, because in an open office space where there's lots of chances for interruption, deep work is really a big problem. Why? Because someone might approach your desk and ask a question, and then you're somehow suddenly not in the flow anymore. And research has pointed out that on average, it takes about 20 minutes to get back into that flow. And 20 minutes is a long time, right? So once you have those 20 minutes and you're really back in the zone and coding it and hacking away that one small but really difficult problem, by then, let's say half an hour passed and another colleague comes asking a question. So if this sounds like your typical day, then there's a problem, right? Then you're never going to be able to approach a long stretch of deep work. So no really interesting things ever get done. So in the book, I talk a bit about ways to try and mitigate that. For instance, a small but stupid thing. If you're interrupted, say to the person, hold it 1 second, write out your stream of thought because you're thinking about something. Just type the stuff you're thinking. It shouldn't be braces or it shouldn't be correct Go or whatever syntax you're working on. Just write out your stream of thought and then answer the person's question. Once you get back to it, it'll help you get into that flow much faster, because otherwise you have something like, what was I doing again? And that thought is lost.
And in that example, is it the act of writing that helps you retain it? Or is it you go, like after you're done talking to this other person, you go back and read what you wrote?
I'll be political and say both. Writing is a good way to help retain stuff in your memory, right? So when you're preparing for an exam and you're writing stuff you find interesting in your textbook and you're summarizing and you're writing with a pen, on a piece of paper instead of the keyboard, which has been proven to work even more efficient to retain that information. So yes, writing is an important part, but of course, when you're writing down your stream of thought, it has to be quick because the person is standing next to you, so you're not really going to grab a pen. You're just going to bash a few keystrokes and then that's done. And then there's a rereading. Indeed, is also an interesting aspect of trying to get back into that thought. And it depends on how long it takes between the writing and the reading, how much context you need to add. So if it's just a stream of thought you're writing down and you're rereading it within half an hour, there's not a lot of context you need to add. But if it's the end of the workday and you're going on a vacation of a week or 2 weeks and then you're going back, then I think it's a better idea to write a bit more about the context, which epic story was I working on? Which of the components did I inspect yesterday or today? Which things do I still need to do? Oh, I still need to ask this to that person. Those are really stupid things, but they really help once you get back into that flow immediately.
And is that something like when you worked on teams that you thought were really effective, did you find that people were writing down these kinds of things more, that they would say like, okay, this is where I left off yesterday and I'm going to pick this up tomorrow and it's kind of all there? Or just curious what your thought is.
Yeah, that's difficult to answer, I think, because in most papers regarding the subject, they claim that technique actually works. And my personal experience also says that it does. But I've seen people not doing it and taking mental notes, and they also have no problems resuming their daily task. I think it depends on the type of person you are and the way you learn. I'm a writer and I like reading and writing, and writing my own stuff really helps me. But I know friends who are visual learners, right? So they don't really like to write in terms of code or words. But for instance, they might make a small drawing, a diagram, a flow chart with a small tree and a bird and whatever. But that helps. So again, I think it depends on the context a little bit.
Yeah, and I suspect this may be somewhat similar, but part of what you mentioned at the beginning of our conversation was that in order to have creative output, you need to have technical knowledge. You need to have this base of knowledge to work off of. And for software developers specifically, what are some of the ways you found that people could effectively retain knowledge? Like if I go and watch a conference talk, and maybe I'm watching the talk and I'm, this is interesting and I'm getting it. And then the next day I remember nothing about what I just watched. So I wonder if you have any thoughts on retaining that sort of thing.
Yeah, that's really simple. Of course, I'll say write it down. But again, that depends on the person. If you want to write it down using just a book, like I do, in an analog and the fountain pen, or digitally in your own wiki or your own digital garden or your blog online or whatever. I guess it also depends on if you want to publish it privately or publicly. But beyond that, the most important thing is to add context. So if you've seen a conference talk and you say, this is interesting regarding the stuff you're working on right now, if you're writing or you're summarizing the thing you saw, try to link it to the project you're working on or to the thing you're working on. That means you're starting to connect things. You're not really just writing down separate isolated cells or nodes of information, but once you start moving that information closer together and linking that, then that's the part where, so to speak, the magic happens.
Yeah, and I think the tricky thing for myself is sometimes I'll take notes, but there isn't really any structure. I'll just have a whole bunch of files, and there is search. So occasionally I can, if I am facing the same problem, I can find it. But if I'm not looking for the right thing, it's kind of just, yes, it's in there, but I have no idea how to retrieve it. Yeah.
Well, there are a lot of digital tools to mitigate that problem right now. One of the most popular ones, I think you might have heard about it, is Obsidian, which is actually just a small layer of software around Markdown files on your own hard drive. And it contains smart searching using the shortcuts that you're used to work with from Visual Studio Code or from IntelliJ. So it's really developer friendly in that sense. It's really easy to publish stuff online in case you want to do it the company-wide. It's really easy to find stuff. You can use OCR software. You can chuck in PDF files. It's really crazy. Yeah, you can easily link stuff, but then you're making those links yourself, right? So, for instance, I learned about Go, and I'm currently working on this Go project. So these two things should belong together. But in Obsidian itself proposes those links if you mention them implicitly. So these are called backlinks, and these are the most interesting ones because sometimes you don't really make that connection, but the software will say, "Hey, maybe this node you took right there could be connected to that node you took right there." So the more stuff you throw at it, the more chances something interesting will be linked together. And then, of course, it's up to you to make a new node, which is the new knowledge you gather from linking those two.
Yeah, that's interesting. Have used Obsidian, but I didn't realize it could infer the topic, I suppose, of notes. Yeah. You've been researching this topic of creativity and programming and ways to get people in a state of mind and in an environment where software projects can be successful. I wonder, through all this time you've spent, are there any specific big takeaways you've had where you felt like, okay, I've spent all these years and these are the things that I think everybody should know, I suppose?
That's a really tough one to answer. I think the biggest takeaway is that creativity is a skill that can be learned, which means everyone can be creative, right? I've had a lot of students come up to me and say, "I'm not really that creative. I don't really know how to do this stuff." In their mind, they're like, "I'm not creative, and that's it. End of discussion." While, for instance, they might also say, "I'm not a really good Java developer yet," because they know they're studying software engineering or computer science, and at the end of the course or within 4 or 5 years in the industry, they'll become a competent or perhaps even a good one. But they have this idea of creativity as a set thing. And that's, to my view, that's incorrect. As soon as you start trying to apply these principles, you'll gradually become better at it. It's just like a muscle, or it's just like learning a programming language.
Yeah, and it's also ties in a little bit to what you had said, where creativity is judged by the people you work with or the people that are exposed to the things you do. And so you could be in an environment where people think like, what Wouter is doing is not creative, but maybe it's just the wrong audience, right? Maybe
that's
what
true.
You're doing, it is creative and it is valuable, but the people just don't see it.
In that case, I guess it's perhaps time to pack your bags.
Right.
Cut your losses.
Yeah, definitely. To kind of wrap up, where can people check out the book and see what you're up to next?
Well, the book is published by Manning. It's called The Creative Programmer. So obviously you'll find it at the product page of Manning itself. And as far as myself, I have a blog called brainbaking.com, and I write about everything that interests me. So I like writing about different topics and linking them in a creative way. So you can also find information about the book and the content itself on my website. Regarding the survey that we talked about, the creative programming problem-solving test is what we call it. You can find it on brainbaking.com/CPPST, or just on the blog and you search for it, you'll find it. It's free, and you can just take it and see whether or not the reflective questions take you anywhere.
All right. Well, Wouter, thank you so much for chatting with me today.
Thanks so much for having me. It's been really interesting.
This has been Jeremy Jung for Software Engineering Radio. Thanks for listening.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can comment on each episode on the website or reach us on LinkedIn, Facebook, Twitter, or through our Slack channel at seradio.slack.com. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under Creative Commons License 2.5. Thanks for listening.